Early aircraft carrier designs emerged as adaptations of existing naval vessels. Key milestones in aircraft carrier evolution include the addition of angled flight decks and steam catapults. Technological advancements in propulsion, radar, and aircraft design drove the development of modern supercarriers. Modern supercarriers represent a significant leap in naval power projection and operational capabilities. Modern aircraft carrier design incorporates advanced hull structures for enhanced stability and hydrodynamic performance. Compartmentalization is crucial for damage control, dividing the ship into watertight zones to limit flooding. Damage control systems include fire suppression, flooding countermeasures, and structural repair capabilities to maintain operational readiness. The design prioritizes redundancy in critical systems to ensure operational capability even after sustaining damage. Nimitz and Ford-class carriers utilize nuclear propulsion systems for power generation. Nuclear reactors generate heat through controlled fission, which is then used to produce steam. The generated steam drives turbines connected to generators, producing electricity for the ship's systems. Power distribution networks deliver electricity to various onboard systems, including propulsion, navigation, and combat systems. Flight deck operations involve the coordinated launch and recovery of aircraft. Aircraft launch systems, such as catapults, provide the necessary acceleration for takeoff. Arresting gear systems are crucial for the safe recovery of aircraft upon landing. Efficient aircraft handling is essential for maintaining a high operational tempo on the flight deck. Stringent safety protocols are in place to minimize risks during flight deck operations. The integration of launch systems, recovery systems, and handling procedures ensures seamless flight deck operations. A carrier air wing comprises various aircraft types, each fulfilling specific roles. Fighter jets provide air superiority and intercept enemy aircraft. Attack aircraft conduct precision strikes against surface targets. Electronic warfare aircraft disrupt enemy communications and radar systems. Helicopters perform anti-submarine warfare, search and rescue, and logistical support. The integrated capabilities of these aircraft ensure comprehensive carrier strike group effectiveness. The Electromagnetic Aircraft Launch System, EMALS, is used on Ford-class carriers to launch aircraft. EMALS represents an advancement over traditional steam catapults. Unlike steam catapults, EMALS uses electromagnetic force for launching aircraft. EMALS offers precise control over the launch process, enhancing safety and efficiency. Ford-class carriers, equipped with EMALS, can launch a wider variety of aircraft with greater reliability. Advanced Arresting Gear, AAG systems, are designed to safely recover aircraft during landing operations. The primary function of arresting gear is to decelerate landing aircraft rapidly and reliably. AAG systems utilize energy absorption technology to manage the kinetic energy of landing aircraft. Modern AAG systems provide precise control over the arresting force, accommodating various aircraft types and weights. Arresting gear significantly reduces the landing distance required for aircraft on aircraft carriers. The reliability and precision of AAG systems are critical for safe and efficient flight operations at sea. Command and control systems integrate radar systems for surveillance and threat detection. Communication networks facilitate real-time information exchange between different units. Decision-making processes utilize data analysis to assess situations and formulate responses. Radar systems provide real-time tracking and identification of potential threats. Communication networks ensure seamless coordination between command centers and field units. Integrated command and control systems enhance situational awareness and response effectiveness. Defensive systems incorporate anti-aircraft missiles to intercept aerial threats at long ranges. Close-in weapon systems, CIWS, provide a last-ditch defense against incoming missiles and aircraft. Electronic warfare capabilities disrupt enemy sensors and communication systems. These defensive systems work in concert to provide layered protection against various threats. Sustaining a carrier at sea presents significant logistical challenges. Food supplies must be regularly replenished to feed the crew. Fuel is essential for the carrier's propulsion and aircraft operations. Spare parts are critical for maintaining the carrier's complex systems and equipment. Underway, replenishment is a crucial operation for resupplying the carrier at sea. Effective logistics ensure the carrier can maintain operational readiness for extended periods. Crew quarters provide essential living space for personnel. Sleeping quarters are designed for privacy and rest. Dining facilities offer communal spaces for meals and social interaction. Recreational areas provide opportunities for relaxation and leisure. Efficient space utilization is a key design consideration in crew living areas. Living conditions are optimized to support crew well-being and operational effectiveness. Onboard medical facilities include operating rooms equipped for surgical procedures. Dental clinics are available for comprehensive oral health care. Intensive care units provide critical care and monitoring for patients. Advanced diagnostic equipment aids in accurate and timely medical assessments. These facilities ensure comprehensive medical support is available. Damage control involves systematic procedures to mitigate the impact of adverse events. Firefighting protocols include detection, suppression, and prevention of reignition. Flood control measures involve containment, drainage, and reinforcement of vulnerable areas. Structural repairs focus on stabilizing compromised elements and restoring integrity. Effective damage control requires coordinated efforts and rapid response. Continuous monitoring and assessment are crucial for proactive damage control. Nimitz-class carriers are a class of 10 nuclear-powered aircraft carriers in service with the United States Navy. These supercarriers are among the largest warships ever built, displacing over 100 tons fully loaded. Nimitz-class carriers are powered by 2 nuclear reactors, enabling them to operate for over 20 years without refueling. Each carrier can carry over 90 fixed-wing aircraft and helicopters, providing significant offensive and defensive capabilities. Nimitz-class carriers have participated in numerous conflicts and operations, demonstrating their versatility and strategic importance. Ford-class carriers represent a significant advancement in naval technology. These carriers incorporate advanced technologies to improve operational efficiency. Improved efficiency is achieved through automation and reduced crew requirements. The future capabilities of Ford-class carriers include enhanced air power and adaptability. Advanced technologies on Ford-class carriers include the Electromagnetic Aircraft Launch System, EMLS. Ford-class carriers are designed to accommodate future technological upgrades and evolving mission requirements. American aircraft carriers are strategically deployed globally to maintain international security. Global deployment of aircraft carriers serves as a means of projecting American power and influence. Aircraft carrier deployment patterns reflect geopolitical strategies and security commitments. These deployments ensure rapid response capabilities and crisis management in key regions worldwide. Carrier strike groups are naval formations composed of various warships and support vessels. Cruisers provide long-range air defense and strike capabilities within the carrier strike group. Destroyers offer anti-submarine warfare and anti-surface warfare capabilities, protecting the fleet. Submarines provide stealth, reconnaissance, and strike capabilities, operating independently or in support. Supply ships ensure the carrier strike group remains operational by providing fuel, ammunition, and provisions. Effective coordination between all vessels is crucial for the carrier strike group to achieve its mission objectives. Anti-submarine warfare, ASW, involves tactics and technologies to neutralize enemy submarines. Carrier strike groups employ various ASW assets, including sonar systems and specialized ASW aircraft. Sonar systems are crucial for detecting and tracking submarines through underwater sound waves. ASW aircraft, such as helicopters and maritime patrol aircraft, extend the detection range with dipping sonar and sonobuoys. Effective ASW requires coordinated efforts and advanced technology to maintain maritime superiority. Air superiority operations involve fighter patrols to maintain control of designated airspace. Air-to-air combat is a critical component of air superiority, neutralizing airborne threats. Effective airspace control ensures safe and efficient air operations by managing air traffic and identifying potential threats. Visualization of air superiority operations includes real-time data on aircraft positions, patrol routes, and threat assessments. Strike operations involve a systematic process, beginning with the selection of a suitable target. Mission planning is crucial, encompassing resource allocation, route planning, and risk assessment. Precision-guided munitions, PGMs, enhance accuracy and reduce collateral damage in strike operations. Effective target selection requires thorough intelligence gathering and analysis of strategic importance. Resource allocation involves determining the optimal deployment of personnel, equipment, and logistical support. Risk assessment identifies potential threats and vulnerabilities, informing mitigation strategies. Aircraft carriers play a crucial role in humanitarian assistance and disaster relief operations. These carriers facilitate the delivery of essential supplies to affected areas. Aircraft carriers provide essential medical care during disaster relief efforts. Aircraft carriers coordinate rescue efforts, enhancing overall operational efficiency. International cooperation exercises foster partnerships between nations. Aircraft carriers play a significant role in promoting interoperability during these exercises. Joint exercises enhance coordination and mutual understanding among participating forces. These exercises improve strategic capabilities and operational readiness. International cooperation through joint exercises contributes to global stability and security. Unmanned aerial vehicles, UAVs, represent a future technology being developed for aircraft carrier operations. Directed energy weapons are being researched for enhanced defensive capabilities on aircraft carriers. Advanced sensors are being developed to improve situational awareness and threat detection for aircraft carriers. UAVs enhance aircraft carrier capabilities through reconnaissance, surveillance, and targeted strikes. Directed energy weapons offer precise and rapid response capabilities against incoming threats. Advanced sensor networks provide comprehensive threat assessment and early warning systems for aircraft carriers. Cyber warfare involves the use of cyber attacks against an enemy's information systems. Protecting carrier systems is crucial to maintaining operational capabilities during cyber warfare. Cyber defense strategies include intrusion detection, threat analysis, and incident response. Cyber warfare capabilities encompass reconnaissance, exploitation, and disruption of targeted systems. Decommissioning retired aircraft carriers involves a structured process of defueling the nuclear reactor. Reactor defueling is a critical step to ensure environmental safety during the decommissioning process. Dismantling the aircraft carrier involves carefully separating and processing various components. Materials from the dismantled carrier are sorted for recycling or appropriate disposal. Proper disposal methods mitigate the environmental impact of hazardous materials. The decommissioning process adheres to strict regulatory standards to ensure safety and environmental protection.